morning everyone, and we are again back with our session on Hadoop. So today what we are going to do is we are going to talk about the Hadoop commands. Okay, so what we have done so far is we have already installed Hadoop in our single node machine, right? So we took our Windows or Mac, right, and we installed VMware Workstation, right? We installed VMware Workstation or VMware Fusion, right? And on top of it, we installed Ubuntu, and we installed Java, and then we installed Hadoop here, and so on. Is not it? So that's what we have done. So this is basically called as a single node Hadoop, right? Wherein you have only one system, and you might have seen after your installation was successful when you did JPS, right? When you did JPS, you might have seen that you were able to see all those demos which we talked about in Hadoop architecture, right? You're like your name node, secondary name node, resource manager, and so on. Now we will learn what is this SDFS, how do you interact with this SDFS, is not it? So as we all know that in a typical real-time production environment, you will have a cluster like this, right? So you will have one cluster. And what is a cluster, guys? A cluster is nothing but a combination of more than one computer, right? You can have a one node cluster, you can have 3 node cluster, you can have 1,000 node clusters. Okay, so let's assume this is a 3 node machine, right? And we have installed Hadoop in it, right? So when I say 3 node, what I'm trying to talk about is I'm trying to talk about slaves. Okay, I'm not even considering the masters here, right? Because when I say 3 node, then if I say one is name node and another one is secondary name node and another one is resource manager, I'm done. It's not it. So when I say 3 node, I actually mean a slave computers. Or let's say you have a 50 node cluster. How does it matter now? Right? If I say I have a 50 node cluster, out of those 50, few nodes would be masters and remaining all would be slave, right? So let's say this is your cluster or of whatever capacity you can think. Now we have all Hadoop installed here, and what you will do is you interact with this Hadoop from a terminal, right? And this terminal is nothing but your edge node. This terminal is nothing but your edge node. In our case, we've just done a single node installation, right? So what you will do, you'll open your terminal here. You log into your Ubuntu and you'll open your terminal. And then here you start writing your command, right? Here you start writing your command. So likewise, in the real time, you get access to this edge node, right? When you join a company, the DevOps team, the admin team, basically they will create one credentials for you, right? And that credentials would be used to log into the clusters, all of the clusters. Okay, so we have this edge node here, and then what we are trying to do is we are trying to connect here, right? So likewise, you'll be able to connect it, but now what we are going to do is we're going to connect to our own machine, a single node, and we will explore all the commands. Okay, now a typical Hadoop cluster, okay, also has the similar file system as of Linux. Okay, for example, if you know, then in Linux we have what? Slash, right? And what is this slash? This slash is basically the root folder, is not it? If you see the Linux hierarchy, everything falls under your slash. And can I say slash is my root? Yes, right? So slash is the location, the starting location of your Linux file system. Similarly, your Hadoop also has the same thing, right? So Hadoop also has the path called slash, and everything, whatever you want to create, they all fall under this directly or indirectly. In our last class, we have seen how to install Hadoop in our Ubuntu, is not it? And that time we chose a username called SD user, right? And our password was Hadoop. That's what we did. So we will now use this SD user, right, to log in to Ubuntu, and then we'll start executing the commands. So if you remember, we created this SD user in our Hadoop as well, right? So we created one user called SD user, which means internally what happens, there would be a folder like this /user/hd user. For every user who is a part of your Hadoop system, you will have a folder like this. Now tomorrow, if I join a company, they will create my credentials, right? And let's say my full name, if my full name is Suraj Ghimire, right, then they might create my alias like this SGHIMIR probably. Okay, and if that is the case, then you will see one name here /user as Ghimire, right? So similarly, for every user there would be a folder like this in all the edge nodes, wherein you can log in and you can do all your operations. So most likely whatever operation you do, you basically save the data into your location itself. You write the job, you have processed the job, the output should be saved probably in your location or maybe in your temp, right? Or maybe in some other shared location, but you're not going to write the data into some others folder because you will not have the permissions to it. Okay, now let us move forward. We will do practical. I'll share my screen and we'll start with our Hadoop commands. Okay, so we will start with this document wherein we will talk about all our Hadoop commands, right? So let's move on. So step number one, log into your Ubuntu system with below credentials. We've already done that. We've created a user called SD user and the password was Hadoop. So I'll go back to my VMware Fusion. It's a Mac, so we will use VMware Fusion. But if you're on Windows, you'll use VMware Workstation, right? And now this is my desktop, right? So this is my desktop where this is our Ubuntu system where we have already installed Hadoop, right? So let me do a JPS, and if you see, I have all the systems, I have all the demos up and running, right? So I have resource manager, name node, secondary name node, data node, node manager, and so on, right? So please make sure that at least these 5 things are up and running. If that is not the case, then you have a serious problem with your installations. Okay, now let's move on. So Hadoop commands usually come in like 2 versions. One is Hadoop FS, okay, Hadoop, and then the command. The other one is SDFS and then the command. Okay, so this is basically the old style Hadoop FS. Writing Hadoop FS is basically old style. It still works and I still use it. Okay, but then there is another approach to do the same thing, that is SDFS DFS. Okay, so this is how you basically write the command to interact with your Hadoop file system. So now from a programmer point of view, you will either do, you will either execute few commands to interact with the file system, like storing the data, or maybe removing the data, or creating a directory, uploading the files, bringing the files, right? So that those things what you do most likely. And the other thing what you would do is probably run your job. Okay, so we will see that as we move on with the program. So let's move on. SDFS command. So now we are going to learn that, right? So remember one thing, that Hadoop does not support VI editor. You cannot go to a file called VI to edit the file. The reason is because the data is all divided into blocks, right? You have no clue where exactly it is stored, and writing the data in that would be extremely difficult. It's not, because half of the data is sitting on one machine, half of the data is sitting on another machine, right? So it will be very difficult to bring that VI editor and bring everything together. That's number one. And the second thing is, you are dealing with huge volume of data. How will you even open a terabyte of file in just a VI editor, right? It is really not possible, because you need to have a lot of memory to load that data, right? And you need a powerful machine. So that's the reason, your VI does not work, and Hadoop does not support editing the file. Hadoop believes on the concept of just read only. You upload the file and that file is just read only. You read the file, you process it, and whatever result you got, you write that data into a new file. But never ever try to like edit the file, because that's not allowed. Number one. Okay, so VI is not allowed. And the second thing is CD is not allowed, because this is not a physical file system. When you try to see the like file system of Hadoop, it looks like a directory, but it is not a physical directory anywhere, right? All those informations are there with your name node. And when you say, give me the data at this location, put the data in that location, that's just a logical path, and that's really not a physical path. So you are not even allowed to say CD and get into this, right? So let's move on, right? We are in our Ubuntu and we would like to create some files and folders in SDFS, right? So the moment when you say Hadoop fs-ls, right, what you get is, you get nothing. And that's what we have seen in our Hadoop installation at the end, right? So let me tell you, we have created one user called SD user. It's not it. So what happens is, in your SDFS, one folder gets created, and that is /user/SD user. This is the default folder that gets created in your SDFS. How do you browse that? You will say Hadoop fs-ls, okay, and then you will give the path. And when you say Hadoop fs-ls/user SD user, what does it do? It basically tries to get the content of this SD user location, right? So let's say enter. It did not give you any content because there is no content, but the folder already exists, right? So the folder already exists, otherwise it would have said the folder does not exist, right? Something like this. Here, no such file or directory. It would have given an error like this. which means you actually have a folder, but then you do not have anything in it. Okay, and when you do Hadoop fs-ls, or just when you do Hadoop fs-ls like this, or if you do Hadoop fs-ls/user sd user, that actually means same. Okay, so I'll go with the document and then we'll understand what all do we have there. Okay, now the first thing what I want to do is let me create a folder. Let me create a folder called data1. So I'll use this command Hadoop fs-mkdir data1, and what it is supposed to do, it is supposed to create a folder for you. Okay, so let's say copy, let me say paste. Okay, now what it will do is it will basically create a folder called data1. Okay, now the same thing you can also do like this. The same thing you can also do like this, sdfs bfs -mkdir. So this is basically a Hadoop 1 command, Hadoop fs. Okay, and this is basically your Hadoop 2 command, sdfs dfs, but then you're free to use any of them. I still use the first command because I'm so much habituated with that. Okay, so sdfs dfs -mkdir data11. So this will create a folder for you. Okay, so let's try to create a folder as well. Done. So both of these would do the same thing. It would create folder called data1 and data11. Next, now if you want to create a folder inside a folder, a recursive folder, right? So you can say Hadoop fs-mkdir -p, right? So when you say -p, what does it do? It first create, see, you're trying to create a folder, right? You're trying to create a folder called data2. Inside that, you're trying to create a folder data3, and inside that you're trying to create a folder data4, right? If you don't give -p, then it will not create the folder, because it is you're trying to create a data4 inside your data3, and that too inside your data2, and you do not have this main folder itself, right? So if that is not the case, then you'll have to create the outer folder, then inner folder, and then inner folder, right? But then you can just say -p, and it will go, like it will create the first folder, and then second folder, and third folder whenever required, right? So this will help you to create the folder and the inner folder and then inner folder in a single go. So let's try to do that, right? So we have also created those folders. Now similarly, let me also try to create multiple folders in a same command. So you can say Hadoop fs-mkdir, and then you can give the folder names, folder 1, folder 2, folder 3, and so on. So we're just trying to create multiple folders and directories. So let's say enter, right? So if you see, we tried our best to create folders by using mkdir command. Very simple, right? But then once you've created the folder, you may be interested to see where exactly these folders are, right? So let us try to understand where exactly you'll be able to see this directory. How are you basically be able to get access to these folders? So the command is ls, right? So it's the same command what you do in your Linux. So you can either say Hadoop fs-ls, or you can say sdfs dfs -ls. Both of them would work for you. Okay, so let me try this. I'll say Hadoop fs-ls. So I'll say Hadoop fs-ls, and what does it do? It basically gives you the list of all the folders, right? So see here, let's understand what we did. Okay, we created a folder called data1. I can see that here. We created a folder called data11. I can also see that here. We created a folder called data2. I can see that data2 here. We created a folder called data4, data5, data6, and I can also see all these folders here. Now, if I go inside this data2, then I'm sure I'll have data3 and data4 folder within that, right? So if you want to go inside that, you can definitely say Hadoop fs-ls, and you may say, tell me the status of data2, right? And it will say data2 has data3. Again, you may say, tell me the status of data2 and data3, right? And it will say the data2 and data3 has data4, right? So that's how you will be able to locate, you will be able to list, but you are not allowed to do a cd. Okay, now let me move on. Now by default, when you are like browsing your own location, then your dot is optional. Okay, your dot is optional. So when you say Hadoop fs-ls, it means your home. And what is your home? Your home is always /user sd user. Okay, your home is always /user sd user. Similarly, when you just say dot means the current user, and who is the current user? SD user. What is the home of that user? /user SD user. Okay, so let's try this out here. So you can say Control L. Hadoop fs-ls and say dot. So this also gives you the same output. Let me also try something like this. Does this work? Does this work? See here, when I said Hadoop fs-ls and tilde symbol, that is what you do in your Linux, right? But then tilde always means what? In Linux environment, tilde always means /home/ your user, right? And this does not exist in your SDFS, right? So now you should not confuse with one thing. Okay, see here, we have logged into this system as SD user. Okay, so if I say pwd, see here, if I say pwd, it will say /home SD user desktop. This is my Linux environment. Okay, and in Linux the default path of any user is /home/SD user, whereas in your SDFS the default path of any guy would be /user/SD user. Okay, so for Linux you have /home, but for SDFS you have /user, right? Okay, so let's do that. So Hadoop fs-ls, and you can say /user. Let me see how many users are there. I have SD user and I have Hive user because I had installed Hive. Forget about this. But then we have SD user, right? In your real-time production, when you just say Hadoop fs-ls/user, you will see a lot of user. All the people who are working on your data engineering profile, you would see their like details here. You'll see their name here, but then you'll not be able to get inside because you do not have a permissions, right? Okay, now let's say Hadoop fs-ls/user/hd user. Okay, this gave me one output. Now if I don't write this, then what will happen? By default it is same. My current user, who is my current user? SD user. So even if you don't write this, then it still means the same, right? It still means the same. But if you see, there is little difference here. When you gave the whole path, you got the whole path, right? When you give the whole path, then you got the whole listing of the directory. But then when you said Hadoop fs-ls, it just said, okay, I'll just give you the data directory name itself without even giving you the list of, without even giving you the path, right? But then you can also do it like this dot, and this also gives you the same output, right? So I hope you're understanding me what exactly I'm trying to convince you here, that every user that gets created in your Hadoop environment would have /user/that user name. Okay, now let's move on. So Hadoop fs-ls/. Now you can also do this, as I have told you that / is always the root of your Linux as well as your SDFS, right? So if you want to know what is there in your /, you can definitely say Hadoop fs-ls/, right? So it will tell you what do you have in your root. Okay, and if you see, I have /user, I have /tmp, and I have some other folder because I created that while running some job, right? But then you should see you have a /user and probably you have /tmp as well, right? So every Hadoop file system and Linux file system has a main folder called /, a main location called /. That's the starting point. Inside that / you have files, folders. Within that folder you have subfolders and so on, right? So that's what we wanted to understand in this example. You can say Hadoop fs-ls data2/data3, right? So see here, I'm saying give me the path of data2/data3, right? And you know that data2 data3 holds a data4, right? And then it gives you the whole path. The reason is because you give the path, so it gives you the whole path. Data2 holds data3 and it holds data4, right? So that's what it is. Now you can also see the files and folders recursively. Okay, let's try to see that. Now look into this. You can say Hadoop fs-lsr/user SD user. I used to say Hadoop fs-ls, but I'm just using R, right? So I'm just using R. So let us try to do that. So I'm saying I give you the content of /user SD user. Okay, so it recursively started looking into all the stuff, and then it has printed whatever the possible directory you can see, right? So see here, it says I have data1, I have data11, I have data2, but then within data2 I also have data3, but then within data3 I also have data4, and then I have a data4 here outside, and then I have data5, I have data6, right? So it basically recursively prints you all the directory structures, right? When I say directory structure, it also means the files as well. Okay, now so you can do this, and it is deprecated, but then you can use -r like this. Okay, or you, instead of using Hadoop FS, as I said, you can use, instead of Hadoop you say SDFS, and instead of FS you can say DFS, right? So that's how you will be basically able to get access to all the files, able to print all the files whatever you need. Next thing is copy a file from local to SDFS. Okay, so we know that we have SDFS, and now what we want to do is we want to copy the file from local to SDFS, right? So let us try to do that. We'll create a simple file and we'll try to load it into our SDFS file system. Okay, so what we'll do is let's go to our desktop. So I'll go to my desktop here. So let me go here. I'm already in my desktop, right? If you are not in your desktop, you can say cd desktop. That's how you get into the desktop, is not it? So I'm currently in my desktop. Now let me create a simple file called word1.txt. Okay, so either you can create it like this, you can say echo hello world, and I want to write it to word1.txt, or you can say vim word1.txt, right, and then escape colon wq. You can also do that, right? So it's up to you what way you want to do it. Okay, so what I'm doing is I just wanted to say echo hello world and write that into a file called word1.txt. So what does it do? It internally creates a file called word1.txt in your desktop. See here, you got a word1.txt here in your desktop. So I can open this file and you should see hello world is written, right? That's how it is. Okay, now what I want to do is I want to copy this file into my SDFS. Once you have written this, let's try to do a cat, right, so that we can confirm that we have something in this file. So cat can be used to print the output of this file, right? And it says word1.txt contains hello world, right? So this data, this file word1.txt, I want to store it in my SDFS now. So what to do? So you can use a command called hadoop fs-put. If you remember, we talked about this in our initial days, saying that the client would copy the file into your SDFS location by saying hadoop fs-put, right? And this is what it is. We're now trying to do it practically. So I'm saying hadoop fs-put, right, /home sd user desktop word1.txt, and copy it into a file called word2.txt. So let's try this out. Okay, so let's try this out. So I'll say copy and I'll go back to this place and I'll say paste. So see here, the syntax is very simple. The syntax is hadoop fs-put, the source, and then the destination, right? So what is the source? The source is your local file system, right? The source is your local file system. What is your destination? The destination is your SDFS, right? So in this case, what I said is, I said I have word1.txt. I want to copy this in my SDFS with the name word2.txt. Okay, so when you do this, let's say enter. When you do this, what happens is Hadoop will copy this file into the data node. How? We have already discussed that in our architecture, right? So we have successfully copied word1.txt to word2.txt. Now you may ask me a question: where will this go? What is the logical path even, right? See, we cannot really tell you on which data node it will go and set. That's none of our business. But what we can understand is on which path it is present, because you have stored some data, you would like to retrieve that data later. If you don't give any path, remember one thing: if you don't see in the destination, you have not given a complete path. You just said word2.txt. So when you don't give any complete path, then by default the path always would be what? /user, is not it? /sd user. Okay, this is the path on your SDFS where this file is stored. This file is stored, right? So how do I confirm that? So you can do like this. You can say hadoop fs-ls, and you can say give me the data of /user sd user. So hit enter. Okay, now do you see your word2.txt is present here? Yes, is not it? And it is a file. Okay, how can you say it is a file? Look into this place. You don't see D when you will see D if it is a directory. Okay, and if it is not a directory, you don't see D. That means it is a file. Number one. Number two, this is your application factor here. If you remember, while we install our Hadoop, we have set our replication factor to only 1, right? And that's the reason this was replicated only one time. In your typical environment, when you're working on a real time, you'll work on cluster where the replication factor would be 3, and you should see 3 number here. Okay, and this is basically the user, this is basically the super user, sorry, the group name, and then this is basically the size of the file. Okay, the directory would not occupy any size, and hence the directory size would be 0. Okay, and this is basically the date of my machine, right? So that's the date at which the file was created. So this is basically the date of my machine when the file was created, and this is the whole path of your file, whatever you were trying to upload. Now let me move on. So we did this, right? But then I can also use a shortcut here. See here, I can say Hadoop fs -put a tilde symbol, and tilde symbol in Linux is always what? /home sd user, right? And there you have your desktop, and there you have your desktop. So you are basically saying, I want to copy the data from my desktop. I know that I have word1.txt, and I would like to copy this in data15/word2.txt, but then data15 does not exist, right? So if the folder does not exist, then you cannot really go ahead and then write a path. It will throw you an error that the data does not exist, and you're trying to write the data into a folder, right? And then the folder does not exist. So let's try this out, and I'll say, I'll go back here, and let me say Control L to clear the screen and say paste and hit enter. Okay, now let's see what does it do. It says no such file or directory data15/word2.txt. So it actually failed because you do not have a data15. Okay, but if you see, you have data data1, right? So you have data1. Now if you just change it to data1, then this file would be copied. Word1.txt would be copied to a word2.txt under your data1 folder, and this should work. It worked, and now you go ahead and check the content of data1. You will see word2.txt. How do you check that out? You'll say Hadoop fs -ls, right? ls data1, give me the content of data1, and it says data1 contains word2.txt, right? So if you see, it says data1 contains word2.txt, and the replication is 1, and then it is just a file, right? So that's how you will be able to confirm that yes, the data is copied. Okay, so this is how you will do, right? So now next, so you can also do something like this: Hadoop fs -put tilde, that is home, desktop, word1.txt, and you can say /word2.txt, right? So when you do this slash, the meaning would be completely different. Okay, so a lot of people get confused. So just because by adding slash, it is basically you are actually trying to say, I want to copy this word1.txt under my slash itself, right? So when you do a slash, you cannot expect that into your default location. Slash, you have started giving a absolute path, right? And it will try to go and copy that into your root location. So you should go and check this in your root location. How do you now verify this? You should say Hadoop fs -ls, and you should verify it on your root, right? So just say ls slash, and then you should see the word2.txt file is present on your root. Now if you just give this slash, do not try to search this in your user home, right? In your sd user home, you will not get that. So the whole meaning changes the moment you write slash, right? So that's what we wanted to confirm. Okay, now so note, please observe slash difference among the SDFS path. So here it is slash, and here there were no slash. So whenever there is no slash, you should understand that this path refers to /user/hd user, is not it? Now let's move on. What if I don't want to give a destination? What will happen in that case? So let's try this out. I want to say Hadoop fs -put word1.txt with no destination at all, right? With no destination at all, and it worked. And the whole idea is very simple. If you don't give any destination, the default destination is what? /user/hd user. That's where you have your that's your home location, right? So anytime you don't give a location, it basically just takes the default location. Okay, so again, how do you verify that? Hadoop fs -ls, enter, and if you see, you can see word1.txt as well has come into this location, right? So that's how you will be basically able to copy. Let us try to see how do you copy multiple files from local to SDFS. I have 2, 3, 4, 5 files, whatever, and I want to copy all of them into SDFS in a single go. Okay, so let's do that. So what I'll do first is, let me try to create a folder by saying Hadoop fs -mkdir word data. So let's say copy this and say paste. So I'm trying to create a folder called word data, and where under my root, right? Slash. So where should I look into that? Hadoop fs-ls slash. You should actually look into this place. You should see one word data, and inside that word data you do not have anything right now, right? So just say word data and you should not see anything. You should not get any output because you don't have anything there. Okay, now what I want to do is I want to create another file called word3.txt. How? By saying echo word3 and then just putting it into a file, right? So either you can use echo or you can use vim, whatever works best for you. So let me say copy, and currently I'm pointing toward desktop, right? So when I execute this command, what it will do is it will basically copy word3, just word3 is the content in a word3.txt, enter, and it will create a file called word3.txt which contains a word called word3, right? Similarly, you can also say vim word4.txt, right? And it opens the editor. Just say you are in insert mode, and then you start writing something. I'll say word4.txt escape wq, enter, and this is what we were doing. We have already done this so many times in our installation lessons, right? So if you see, you have now word3.txt and you also have word4.txt. Okay, now let's see what we want to do with this. So we have word3.txt, we have word4.txt. Now I would like to keep all these two files into word data, and word data is the folder which we had created recently, right? So now my command would be this: hadoop fs-put or sdfs-put, okay, whatever works. Now I'm saying, see, I'm already in my desktop, right? And that's the reason I just wrote word3.txt and word4.txt. We wrote word3.txt and word4.txt just because that is present in my desktop, and currently I am located in my desktop, right? If you are into some other location, then you must give a proper path here, right? But in my case, I'm already in my desktop, so I said word3.txt and word4.txt, and I'm trying to copy these two into my folder called word data which we recently created, right? So let's say enter. Now something happened, and let us try to verify that. Now how do you verify, guys? It's very simple. You will say hadoop fs-ls or sdfs-ls, right? So you can say sdfs-ls, and what is the path? Word data, right? And you should see word3.txt and word4.txt inside that, right? So that's how you can confirm, okay, my data is moving, my data, I'm able to copy the data from my local system to my SDFS, right? And that's how it is. Now we did a put, right? So we understood this, right? Now there is one more approach. See, there is an approach called put, and there is also approach called copy from local. Copy from local also will do the same thing, okay? So in this example, I'm also trying to do the same thing. I'm saying copy the data from my local file system, that is my Ubuntu, right? What are the files you want to copy? Word3.txt and word4.txt. Where do you want to copy? I want to copy it in my current working SDFS location, right? And what is my current working location? /user SD user. So let's try to execute this also, right? So I'll just say copy, and if I say paste, this would be all. This should give me an error saying that the file already exists. So give me a minute. I'll just clear those files because we've already done that. And hadoop fs-rmr word3.txt word4.txt. All right. So now let's do that, right? So I'll say hadoop fs-copy from local or sdfs-dfs copy from local word3.txt and word4.txt. So I'm inside my desktop right now, right? I'm under my desktop, and in my desktop I do have my word3.txt and word4.txt, and I'm saying I want to copy them, right? I want to copy them where? Into dot. And what is this dot? Dot always means my present working directory. So when you do this, you again say hadoop fs-ls, where to search your current working directory. So just hit enter. That will also be okay, right? So if you see, you have word3 and word4 properly copied, right? So let's do what? Let's try to remove this word3 and word4. I'll say hadoop fs-rmr, and let me say word3.txt, okay? And let me also do that word4.txt. I'm removing both the data, and let me try to again say hadoop fs-ls. So if you see, you do not have 3 and 4, right? But then what I would like to do is I would like to copy word3 and word4 from my desktop location to this place, right? And since I'm already in my desktop, I don't really have to give the complete path in this case, right? I can just say word3.txt, I can just say word4.txt, and the data would be copied into that particular location. Now let's move on. So we have also done this, right? So you can do it this way, or you can also try something like this. DFS, SDFS, copy from local, word3.txt, word4.txt. But then let us see what does it do. Okay, let us see what does it do. Okay, now I will say paste. I will say paste, but then I know that my word4 is already added in my location, so I'll say word6. Okay, let me say word6.txt, and let's see what does it do. Now let me say hadoop fs-ls. Now if you see, what happened was word6.txt was created, right, with the content of word3.txt. Don't get confused. So the difference here is, in the first example you had one destination here, and hence all these two things were your source, right? But in the second example, you have not given any dot and all. So what happens? This becomes your destination and this becomes your source. And then Hadoop FS hyphen a copy from local did the same thing for you. So note that SDFS path must exist. So whenever you're giving, like the path to copy, please make sure that your SDFS path exists. Okay. So when you do this, what happens is, in the real time, you will have a lot of cluster. Let's say 300 node cluster, right? Your file is what? Your file is a big file of 1 gigs, and you have a block size of 128 MB. And you said Hadoop FS hyphen put, or you said Hadoop FS hyphen copy from local, right? And what would it do is, it would basically trigger that command to the name node, right? And the name node will tell, hey, I have 300 nodes, but then these are the possible places where you can store the data. And those information would be given back to your put or copy from local clients. So these are the clients. These guys will start dividing the data and start sending the data into the appropriate data nodes. And that's what we discussed in our previous lessons, is not it? So that's how it will basically work. Okay. All right. Now let's move on. Now what we want to do is, I want to copy the data from a file present in tar.zz. Okay. So this is really interesting. Let's try to see that. What I'll do is, I'll go to my directory and let me create a folder called data. Okay. So paste mkdir under my desktop, create a folder called data. You can do this, or you can simply do this because you're already inside your desktop, right? So hit enter. This will create a folder called data. Done. Next, now let's do what? Let's try to copy some content into a folder. So in my desktop, I have a data. Inside that, I would like to create a file called fruits.txt, and I would like to add some text to it: apple, banana, mango, and so on. So let's copy this and then say echo of this. So what echo does? Echo will basically give you the output. That output is being redirected to a file called fruit.txt. Done. Now similarly, let us try to do the same thing with our other file, right? So let's copy this and say paste. So now I'm also trying to write cricket, football, hockey into a file called sports.txt. Done. This is also done. Next, now once this is done, let's go to our desktop. Okay, I'll go to my desktop. Already I am in, right? And then let me try to zip those files, right? Let me try to zip those files. So I'll say paste. So we have pasted this data, we have zipped this file into a file called data. Now if you see, I basically got a data.tar.zz, right? So what I did is, I created a zip file, and this zip file contains folders, right? This zip file contains this data all together, is not it? So what I'll do is, let me try to delete this. Okay, move to thresh, and let me try to extract this. Open. Okay, so see here, what do you have it? You have a folder inside this zip, and inside that you have fruits and sports.txt. So we have created a zip file. That zip file contains sports.txt and fruits.txt, right? Now you can assume this as your production log file, which were zipped, and that contains some informations. That contains a lot of log file of a particular day. Now what I want to do is, I want to extract that, and I would like to, copy only a particular file into my SDFS. Let's see that. Okay. So what I would do now is, I would say Hadoop FS hyphen mkdir fruits and sports. What will that do? That will create two folders, fruits and sports, under your /user hd user, right? Hit enter. Now let's go into that Hadoop FS-ls. Let's go inside that, and you should see a fruit and sports, right? This is the folder which you have created just now. Now what I want to do is I want to extract this data tar.gz, right? And it has two files, fruits.txt and sports.txt. I would like to copy them into the respective folder in my SDFS, right? Possibly this is something which you would like to do. So what you could do is you could do something like this here: tar zxvf data.tar.gz, right? Data slash fruit.txt -o pipe symbol Hadoop FS -put, then a minus symbol here, and fruits.txt. So what does it mean? It means the output of this file, this zip contains this path, data slash fruit.txt. Let me extract the output of this file, and that output should go to your Hadoop FS -put. Now here if you see, you have a hyphen, and what is this hyphen? See, when you use put, we have already used put here, right? And in the put, what was your first command? Always your source, is not it? So now you are saying hyphen is my source, but where exactly you're going to get the data from? You are actually going to get the data from this stream, right? From this output, which means here this hyphen is acting as a placeholder, and the data would come from this place. The data would come from this place, right? By after unzipping your tar.gz. So this output would come here, and then this I would like to store it on my fruits.txt, right? So let's try to do this. So copy this and say paste. Right now we did that. So we have copied fruits.txt from a zip file, to be very honest, right? And you did not extract that. Think about it. In the real time, you may receive one zip file which may have a lot of other files, and you are really not interested to extract everything. All you want to do is just copy few files from there and then push it to your SDFS, right? So that's what you can do. Now similarly, let me also try to do it for the other file. Now here I'm using copy from local. In the previous example I used put, but here I'm using copy from local. Okay, so I'll tell you what exactly is the difference between them. Please stay for some time. This is also done. Now the next thing is, see, once we have copied this, why not verify that? Is not it? So let's say Hadoop FS-ls. Where should you look into? You should look into fruits, right? And I expect a fruit.txt here. It's there. And if you see, the size is not empty. It's not, there is some data in it. Okay. Similarly, let me say sports, right? And if you see, there is a file called sports.txt with some size in it, right? Now if you want to view the content, you can use cat. Okay, so if you want to view the content, you can use cat or you can use text. So let's do this. Hadoop FS-cat fruits.txt. Okay, this will help you to get the content of this fruits.txt. It will display you the content here, and it says the file contains apple, banana, mango, right? Similarly, you can do the same thing with your other file, sports and sports.txt. You can say Hadoop FS-text. That can also be done, right? sports/sports.txt. Okay, so it says cricket, football, and hockey. So what we did is we had the data in a zip. We uploaded that into SDFS. We tried to see if the upload was successful by just doing a Hadoop FS-cat and text. Now you may ask, what is the difference between this cat and text, right? So text supports encoding and cat does not. And what do you mean by that? Sometimes what happens, when you are processing the data, your data may have some special symbols like Hindi script or Tamil script and so on, right? And those when you try to do a cat, it will not show you those characters, right? You may see question marks probably. Okay, but then if you try to do a text, then you'll be able to see them properly, exactly, because it supports encoding. Okay, so sometimes you may have to work with data with some characters. For example, if you take if you take an example of SMS, right? Most of the time we receive SMS in English, but then you might have also noticed that few companies sends you SMS in Hindi probably, right? And then you may want to process that also, right? So if you want to really process that in one or other way, then you should definitely use if you want to see that, at least for now, right? So if you want to see those messages, then you should basically use text because it supports encoding. Okay, let's talk about this. Now I want to explore this more. Hadoop fs hyphen put hyphen. What is this hyphen? I know that Hadoop fs hyphen put can copy the data from source to the destination, right? We were doing it since long time, but then I want to understand this as well. Let's understand what exactly it is. Okay, so what does it do is it basically will allow user to enter the data. Okay, so let's do that. So I'll say Hadoop fs hyphen put minus and demo.txt, hit enter. Now see here, it is waiting for you to write something. Okay, it's waiting for you, it's not executing, but it's waiting for you to write something. And I'll say hello world, how are you? Okay, and I'll hit enter. Let's do that. And let me say command C right now. Okay, I'm using Mac, so I'll say command C and let's see what does it do. I'll say Hadoop fs hyphen ls. So if you see, you have a demo1.txt and you have some characters recorded here, right? And what I used is I used command C, right? So let me also update this here. If I have not done this, keep writing your data, and when you are done, I should have said press enter and then press Control plus C, use command plus C in Mac. Okay, so that's what you should basically do. The same thing can also be done by using copy from local. So if you see, the put can also do the same thing, and a copy from local can also do the same thing for you. Now the question would be, what is the difference between this put and copy from local? Is not it? When you say put can be used to copy single source or multiple source from local file system to destination file system, and it can also read the data from standard inputs and write it to a destination file system. So if you have a requirement to read it from some other stream, that also supports. Okay, but then copy from local is strictly when you want to read the data from local file systems only. Okay, and hyphen will allow a user to write the data, right? But then that is supported in both the cases, but then otherwise your copy from local will support only local file system. Okay, whereas your put can also support some other standard input file system to write the data into SDFS. Otherwise, if you look into the API documentation and all, copy from local extends put. So which means put is a superclass and copy from local is a child of it, and there is no other difference between these two. Now let's move on. Now what we will learn is append multiple local files and upload it into SDFS in a single file. So let's understand the requirement. Okay, so I have a desktop. Inside that I have a data folder, and inside the data folder I had fruits and sports, right? So I think we have deleted that, but then what we can do is probably extract this again, right? So okay, so what I did is I extracted my folder back, right? Data.txt, and this has got fruits and sports. Now let's see what exactly we are trying to do in this next example. We said cd desktop data, go inside the data and do a ls, and you saw that it already has a fruits and sports.txt, right? So I'll go inside this. Let me go inside this through my terminal. Okay, so I'm in my desktop. I'll say cd data. I'm inside this, done. Next, what I want to do is I would like to use a command append to file. Okay, so I'll say Hadoop fs hyphen append to file fruits.txt sports.txt into fruits underscore sports.txt, which means merge the content of these two files into a single file in my SDFS. Okay, so I'm saying Hadoop fs hyphen append to file. You take this file, append them and keep it on fruits underscore sports.txt in my SDFS. So what it will do, it will create a single file in your SDFS, right? It will create a single file in your SDFS called fruits underscore sports.txt, which will have the fruits as well as the sports details, right? So let's do that. Okay, now let's try to verify this, and what we get is we get apple, banana, mango, cricket, football, hockey, and so on, right? Done. Now let us try to do something like this as well. I want to try it out. What does it do, right? I would say maybe star.txt, whatever I have a lot of stuff. I have two files, and let me say fruits2.txt, and let's see, hit enter, and let's see what does it do. Okay, so it looks like it executed this successfully, but then I also want to do a cat on it, and I'll say 2.txt. right? So this also did the same thing. So if you have multiple file, you can also use some sort of wildcard characters, and then this would also give you the same output altogether. So let me copy this. This is done, right? Now read the data from SDFS using get or copy to local. So we understood put. Now we are trying to understand get. What does this get do, right? So get can be used when you want to download the file from your SDFS into your local file system. Okay. So for example, you can do something like this: Hadoop fs-get, okay, and you may say this is the file. See here, this is the file, and if you say get, then this is your SDFS, right? Get can be used to bring the data from SDFS to local. So your first path would be your SDFS path, okay, and your second path should be your local path. And if you see the difference, slash user SD user means what? SDFS path. Slash home SD user means what? Ubuntu path, right? So you're trying to bring the data from SDFS to local, right? So let us try to do this. So I'll just copy this, paste. Okay, now assuming this file exists, assuming word3.txt is present, it will basically bring the data into my slash home SD user. You did not see it here because this is a desktop, is not it? So what you should do is go here, right? Go here, and this is your home, right? And here if you see, the word3.txt was uploaded, right? So it was downloaded. So let me remove this, and let me try to do this again. And if you see, you will get one file here, right? word3.txt, and this file has the content. If you had a content there, right? So you had the content word3.txt, you had some content in word3.txt, and that content was downloaded. The file was downloaded. So you can use this get command to download the data from SDFS to local file system. Okay. Now again, let me try doing something like this. I'll say mkdir my directory, right? So I'll go back here and say mkdir under slash home, right? So you're doing it on your Linux. Under slash home SD user, I would like to create my directory. So what you will see is, you should see a my directory here, because this is your home. So look into here somewhere, you should find my directory. This is the one which we are talking about, right? It is empty right now. Okay, now let's move on. So now I'll say Hadoop fs-copy to local. I'm trying to do a copy to local now, right? I'm trying to do a copy to local, and I'm saying slash user SD user word3.txt, and copy this into this particular location. So this would copy word3.txt into my folder called mydir. So once this is done, go to your mydir, and if you see inside your mydir, you have word3.txt. Okay, but then I also want to do something like this. Let me say mydir4. Let's say, right? I am saying copy the data word3.txt into something called mydir4. I just wrote that, and I'm sure that I do not have mydir4 here, right? And let us see what does it do. Okay, it still succeeded, right? It still succeeded. So do you mean a folder got created? Let us try to see that, right? So if you see this example, now if you see, the mydir is basically a file, right? So don't assume that you gave the path, that means it becomes a folder. No, right? In the above example, mydir was a folder. So what happened was word3.txt was copied inside that. But if you look into this example, mydir4 does not exist. So what happened was, this was copied to a file called mydir4, right? See, how is this different than this? Not at all. Okay, in this example we said word3.txt, you copy it into a file called word3.txt, but it is not necessary that you should have an extension for a file, right? You can have a file without any extension, and that's what it has done in this case. You can also set a replications. Okay, you can also set the replication factor to something else. You can also do that. Okay, now look into this. You can say Hadoop fs-set rep 2, okay, and then slash user SD user word3.txt. So let me try to set the replication factor of this to 3. Okay, sorry, to just 2. So I'll say paste Hadoop fs set rep to 2 of a file called word3.txt. Okay, it said replication 2 is set. Now let us say Hadoop fs-ls. Okay, I'm more interested to look into this word3.txt. I'm more interested to see this word3.txt, and what is the replication it is showing you now. It is showing you 2, right? It is showing you 2. Okay, now If you see, it is showing you 2, right? Now see here, although it's so successful, still there would be only one replica. The other replica would not be stored because this is a single node machine. And even if you say 2, that does not mean that 2 replica were created. That means I'll try my best to maintain 2 replica, okay? But whether it will maintain or not, that depends. In our case, it is a single node and it is not going to create the second replica. How can you say that? Let me prove that practically. Now I will do something like this, okay? I'll say Hadoop fs hyphen set rep hyphen w2, and then I gave the path name, the same name, okay? And let me hit enter, okay? Let me hit enter. What happened here, see here, they're saying replication 2 is set, waiting for w3.txt. So what does this do? When you said hyphen w, that means it will not come back to you unless and until 2 replicas are met, which is not going to happen anytime because it's a single node machine, okay? Now what will happen is this will take forever, right? You go for a long drive and come back and then it will still be on the same place because the replication would not be met. And since the replication would not be met, you will not be able to it will not be able to replicate, right? So it is not going to come back like here. It will be just here, right? So, and it is just because it does not really replicate now. It is basically a instruction that please try to maintain a replication factor of 2. But then if you do not have 2 nodes or 3 nodes, at least 2 nodes, why will exactly it will do a replication? It does not make any sense, right? So which means if you have just a 3 node cluster and if you set the replication factor to 5, then it is not going to meet 5. It is going to meet 3 maximum, whatever is possible, but not 5.